Now for a more interesting example. Here we're going to see an essential difference between the pi calculus and a lot of programming languages. With a lot of languages, when you write a term, if there are two different ways of rewriting it, then eventually they come back together. And so even if there might be a few different choices, ultimately there aren't really distinct futures of a given term. But in the pi calculus, because the processes are like independent agents, there's many different possibilities. So here we can kind of think that two people are bidding on something. And this is like the auctioneer, and two people are racing to bid on some prize fee. And so they're submitting their channels that will grant them access to that. And so there's two different results here. What are the two possible forward actions that can happen?
Y bar B.
Yeah. So maybe if the Y one wins, then it gets through, and the other one is left hanging.
So are you using a rule that if P goes to Q, then P pipe R goes to Q pipe R?
Yep. So this is one where, they just bid like a nanosecond before, and so the Y won, and then vice versa. If Z wins, then Z has access to the prize, and Y is left hanging. And after this, there's no reason why these terms will ever come back together again. These can represent like alternate histories. Yeah. So this is the fact that the pi calculus is non-deterministic, and this is basically this and the opposite case where two people are listening and one is outputting. Those are kind of the two basic sources of non-determinism in the language, because it's going to be up to the physical implementation and come down to the actual hardware signals, which one gets through first. So just for fun, we can make this more realistic, like an actual auction, without much more effort. And this starts to give a sense of how expressive this language is. So before, they were just kind of announcing their bids by giving the auctioneer a channel over which to give them the prize. But they weren't actually having to pay anything. If you actually want to pay something, then on that thing that you're sending them is presumably some kind of wallet. And so then if your bid is accepted, then you need to actually send some money so that you get the prize. So the auctioneer is listening on a channel, but now once it receives a bid, it's going to listen on that channel of the bidder and receive some money. I call it the payment. Yeah, fee for payment. And then once it receives the payment, then it will output the prize. And same on the other side. So the Z is outputting some money as well. So you all see why this is doing what I just described? So what's a first reduction that can happen? So it's just like before, except now there's going to be more processes left over after the communication. So for example, if Y gets through first, what will be the result?
The A bar Y disappears because it was used up.
Yep.
And you're just left with Y bar M over there.
Yeah.
And then you have pipe, and the A of X disappears because that got used up.
Yeah.
Y is now substituted for X in the next two terms.
Yep. Good. So it's linked up, the bidder has linked up with the auctioneer, and now it's ready to transfer the money, and then it will receive the prize. So that guy's left behind. Now you have the communication between the receiver and the bidder, and now this disappears into nothing, and you get that Y outputs.
As it stands, the auctioneer has thrown out the money. It doesn't do anything with P.
Yeah. There's a lot of holes in this, but it expresses this. I mean, this essentially expresses the basic idea of an auction, which I think is pretty cool because it's just like some symbols. It's an example of how this is a really powerful language. It's also an example of how names really make sense as a primitive resource because they represent access to something. Here, for example, they could have been bidding on an important prize like the exact value of E. So somewhere, this is a channel that when you listen on it, it's somewhere out there on the internet, it's outputting the exact value of E. And so the prize, it makes sense to think of the channel itself as a prize, because then once you get that access, that key, all you have to do is listen on it and you receive some valuable data. So at first it feels a little weird that all you're doing is passing around names, but as we'll get a better feel for it, they're really just keys to important data.